All right, in this video, let's talk about some of the advanced features that we may have seen in other slides and other videos, but I want to go back and let's catch up with them. Right, so we talked about input, individual channel control. All of our levels are mixed together to make a mix. Our mains controls the overall volume, and then we output that to the amplifier. But now let's look at some of the advanced controls that are here. And in our input selection, right, or our input section and input sensitivity, there's a control known as an HPF, or a high pass filter. And what a high pass filter does is it passes all of the frequency above a certain point, right? Basically, it's a bass cut, right? It takes out ultra low frequencies. And if we think about, I don't know, a singer or a flute player or many applications where we would use a microphone, the source that's singing into that microphone or playing into that microphone is not going to generate any audible sound below 80 hertz. And below 80 hertz it sounds like a rumble. It's really low, right? And boomy. And sometimes we want to just go ahead and just eliminate that. So you can see in this little graph down here, by engaging the high pass filter, what it does is it just very sharply fades out anything that's below 80 hertz. And it helps eliminate rumble, especially on vocal microphones. You could think if somebody like bumps the microphone or bumps the microphone stand, right, that's going to generate a thud. And by using a high pass filter, you're able to go ahead and just eliminate that thud sound or diminish the thud, right, by using a high pass filter. So that's the high pass filter. Next is what's known as a compressor. And compressors can be very elaborate. This mixer provides us with a very limited one. But what I'll do is try and explain what a compressor does. And I want you to think about a singer that can belt. And when I say belt, that they have the ability to get really loud and powerful. They sing at their normal volume most of the time. But at certain points in the song, they just really cut loose and are really powerful singers. Without a compressor, you would have to go to that individual volume knob and turn them down when they belt, and then turn them back up when they're done, right? So that you can compensate for the fact that they've just, in that brief moment, have gotten very loud. A compressor is a way to do that automatically. Down here in this graph, you can see this is just output strength, and as the signal gets stronger, the output just keeps getting stronger and stronger. What a compressor does is at a certain point known as a threshold, it starts to automatically turn down the volume of a channel, right? So that as a singer gets louder and louder, their volume gets less and less and less. And it's a way that we can compensate for input signals that will occasionally get a lot louder than what we're normally set up, than what they normally do, right? So it compresses the signal a little bit, right? So that we don't overdrive the system, and so that they don't suddenly get so loud that we just can't stand it, right? Typically, we're going to want to leave at the less compression that we use, the better. But when you need it, it's good to have. So that's compression. The next thing that we'll talk about, and the last, is going to be this. It's a button, and in this mixer, it's right in the middle. Other consoles have different ways to access this, but it's known as phantom power. And when we study microphones more in depth, you'll find there are some microphones that are strong enough that they make their own electrical signals that they send back to the board. Others are much more sensitive, and those super sensitive mics actually required either a battery on the microphone or to be sent power from the mixer. And what phantom power does is sends a 48 volt signal to the microphone, right? The microphone is then able to use that power, that voltage, right, to be able to create a very sensitive signal that then the soundboard could read. If you have a microphone that's plugged in and not working, you should really check the manufacturer, because applying phantom voltage to a microphone that's not designed to have phantom voltage can be damaging. For everything we have in this class, if you have a microphone that's not responding, you may want to check and see if it requires phantom power. And if it requires phantom power, we can just press this button and it will send that 48 volts to the microphones so that they can work correctly. So that's phantom power, and we'll come back with more in a minute.